All right, class, today we're studying section 10.3, which is vectors in a plane. We are going to be able to represent vectors as directed line segments, determine the magnitude of a vector, and perform vector operations. Vectors are used to represent quantities that have magnitude and direction. There are two important points in a vector. This is the initial point, and this is the terminal point. The initial point can kind of be considered your starting point, and the terminal point would be like your stopping point. This vector is traveling in the positive direction. Magnitude and direction are the two important things for vectors. A vector is considered to be in standard position if its initial point, so its starting point, is at 0, 0. It is represented then by its terminal point. So technically this vector would be the vector at 0, 0, and then to whatever point would be x, y. The component form of a vector can be found by using the slope. This is also how we know the direction. It's important to know what your initial point is. So our initial point is the point 4, negative 7, and the terminal point is the point 1, negative 5. All we have to do is subtract the terminal point from the initial point. So I'll start with the x values. I'll do negative 1 minus 4. So that would be negative 5. And now I'll cover the y values. 5 minus negative 7, which would be plus 7. And 5 plus 7 would be 12. So this would be the direction of the vector. Down 5, or sorry, to the left 5 and up 12. The magnitude of a vector can be found by using the distance formula. The notation for the magnitude of the vector is this double bar. The v is just standing for the vector. The magnitude is always going to be a single number. A unit vector is a vector that has a magnitude of 1, and a zero vector is a vector that has a magnitude of 0. So let's go back to our previous example. Let's determine the magnitude of this vector. We could do the distance formula one of two ways. We could use the vector that we found and use the point 0, 0, or we can use our initial point and our terminal point. I like to use the vector that we found because I know that I'm just going to use the numbers. Remember, the distance formula is similar to that of the Pythagorean theorem. You have to figure out how far apart your x values are, and then figure out how far apart your y values are, square them, and then square root the whole thing. So the magnitude of this particular vector is going to be the square root of 5 squared, or negative 5 squared plus 12 squared, which is 169. So the magnitude of this particular vector is 13. We'll talk more about what the magnitude of a vector means later. You can also perform several operations with vectors. Any vector can be multiplied by a scalar. A scalar is just similar to like the leading coefficient. So in this case, 3 would be our scalar. All we have to do is multiply both numbers by 3. So it would be 3, 6 when I multiply the scalar. You can add two vectors as well. adding two vectors, all you have to do is add the x components and the y components. So 2 plus 4 is 6. 5 plus 1 is 6. You can also subtract vectors. It's similar to multiplying by a scalar. First, technically, I should distribute or change the signs of both of these numbers in the second vector. So I end up adding. So 2 plus negative 4 is negative 2. And 5 plus negative 1 is negative 4. We'll talk more about how to perform operations with vectors in class. Please write down any questions that you may have, and we'll go over them in class.